All right, everybody. Welcome to the week 23 test. Let's get started. So, first of all, it asks for the amplitude. So, I've got this function here, and I know that the amplitude is always the absolute value of this number. So, amplitude in this case is 3. The vertical shift is going to be 4 units down, and I'm getting that from this right here. That's my vertical shift. Next, my horizontal shift is going to be this number right here. So it is going to be pi over 3 units, and it's always the opposite direction you would think because it's in parentheses. So it's going to the right. And finally, the period is going to be equal to 2 pi over b. That's my period. And my frequency, my b, is actually 1. So that's going to be 2 pi over 1 because nothing is given there. So yeah, my frequency is, or my period is just going to be 2 pi because my frequency was 1. All right, next up, I've got this equation right here. Whenever I have one of these, it says determine the exact period. I will start with that. So I know that the equation for period, again, is equal to 2 pi over b. So in this case, that will be 2 pi over my period, which is pi over 8. So when I do 2 pi divided by pi over 8, that's the same thing as doing 2 pi over 1 times 8 over pi, because dividing by a fraction is the same thing as multiplying by its reciprocal. So again, this is a pi. It's not really coming out very clearly, so I'm just going to rewrite that. That is, again, 8 over pi. These are going to cancel, and I'm going to be left with 8 times 2, which is 16, over 1, which is just 16. So my period is going to be 16. My amplitude is 2, because again, it's the absolute value of this number here. And the midline value is going to be 1, because that is my vertical shift. So if I'm going to sketch it, I'm, for your benefit, just going to do it in a couple different colors. I'm going to sketch my midline in blue. So my midline's right here at 1. And then I know because it's cosine, it's going to go down below the midline to start because I've got this negative 2. So I'll do this in red. So I know my first value is going to be 2 units below the midline. I know my period is 16, so I'm going to just make it easy and I'm going to graph one period. So I'm going to say that this is 16 over here, and I'm going to say that this is negative 16 over here. That means that this is going to be 8. This is going to be negative 8. This would be 4, 12. I don't need to graph every value though, and I'll just keep doing my points now. So it starts below. Over the course of one period, it will return back there. One period is one full cycle, which means halfway it's going to be 2 units above. It's going to be my amplitude above my midline. So that's up 1, 2 up here. And it will look something like this. Then I'm going to do it over here as well. So it will do one full cycle and return back over here in the middle. I have my peak, goes up, turns around. Ooh, that one was even better. Nice. And there I have it. I sketched a full period on both sides of the y-axis, and I have labeled the scale. This, of course, should be a 1, this should be a 2, this should be a 3, this will be a negative 1, negative 2, negative 3. Next up, Evie is on a swing thinking about trigonometry. No, seriously, she is. And she realizes that she can model her trip using this function here. So it says, what is the range? So I know that the range of any function is going to be the difference between the y minimum and the y maximum. So if I have any sort of cosine function, it will look something like this. And Evie realizes her midline is at 5. Realizes the maximum is 3 units above the midline because of the amplitude, which is 8. And the minimum is going to be 3 units below the midline, so it'll be at 2. So that means that my range is going to be from 2 to 8, which is right here. That's the range of Evie's height. 3 above the midline is 8, 3 below the midline is 2. All right, back to some review now. So we've got these log equations. So I'll just write it out. I've got log k equals c log v plus log p. Okay, so I want to get k by itself. So to do that, I need to get rid of the logs. And to get rid of the logs, I need to condense them. I know addition turns into multiplication, but until I get rid of the c, I can't combine them. So to get rid of the c, I'm going to turn it into an exponent. So I can rewrite this as log k equals log v to the c power plus log of p. Then addition becomes multiplication, so I've got log k equals log v to the c times p. That's all now in the same parentheses. Then, because I've got logs on both sides, I can cancel them out, and I get k equals v to the c times p, which is right here, option number 1, v to the c, p. Solve by completing the square, no problem. So the first thing I do is I add 4 to both sides, and I get x squared minus 8x equals 4. Divide this by 2 and square it, negative 8 divided by 2 squared. So negative 8 divided by 2 is negative 4, squared is 16. So I'm adding 16 to both sides. Then I can rewrite this side as a perfect square trinomial. 4 plus 16 is 20. This is a perfect square trinomial, would be x minus 4 squared. Now I will take the square root of both sides. So I get x minus 4 equals positive and negative radical 20. Add 4 to both sides, and I get x equals 4 plus or minus radical 20. And then I just have to simplify this root here. So I know the square root of 20 is equal to the square root of 4 times the square root of 5. So that would be 2 radical 5. So I get 4 plus or minus 2 radical 5 is equal to x. Got my answer. If I want to be sure that's right, I can check it by graphing. And I'm not 100% sure. I could have made a silly mistake somewhere along that process. So I'm pulling up my calculator. I'm going to go to my y equals screen. Well, first I'm going to figure out what 4 plus radical 5 is. Excuse me, 4 plus 2 radical 5. Okay, that gives me 8.47. So then I'm going to go into here and I'm going to graph x squared minus 8x minus 4, set it equal to 0. And then I'm going to see where they intersect. And I get the minimum is negative 0.47. And I guess if I want to find the minimum, I'm going to have to do 4 minus 2 radical 5. And I believe that is what I wanted. So I'm just going to drag that in here to check, trace, intersect, and find that minimum value again. And yeah, sure enough, that looks great. In the maximum point, it looks like it's up here at 8 point something. So I know I'm in great shape. All right, solve using the quadratic formula. Well, this is the same equation, isn't it? So I better get the same thing. Quadratic formula, opposite of b, plus or minus square root b squared minus 4ac over 2a. All right, here it is. So opposite of b is 8 plus or minus the square root of b squared, which is, I'll just do it like this. All over 2 times 1. So this will be, let's simplify under the radical first. Negative 8 squared minus 4 times 1 times negative 4 gives me 80. So I get 8 plus or minus the square root of 80 all over 2. Square root of 80, I'm going to simplify that now. So that would be 16 times 5. Square root of 16 is 4, so I get 4 radical 5. So this is going to be equal to 8 plus or minus 4 radical 5 over 2, and then I can divide everything here by 2, and that would give me 4 plus or minus 2 radical 5. 8 divided by 2 is 4. 4 divided by 2 is 2. 4 plus or minus 2 radical 5. Same thing I got there. Hey, it worked. All right, here it's asking me to factor completely. And it turns out I didn't have the signs. So I'm hoping, yeah, I can screenshot this right from the test. Good. All right. Here we have it. So if I'm going to factor this completely, I'm going to factor by grouping. I can factor an x squared out of the first half of this, and then I'm left with 3x minus 5. Then I can factor out a 16 from the second part, and I'm left with 3x minus 5, negative 16. Because negative 48 divided by negative 16 is 3. 80 divided by negative 16 is negative 5. Then I'm left with x squared minus 16. I'm having a little red flag in my head because I know that's a perfect square minus a perfect square. So then I can factor this right here, this x squared minus 16, into x plus 4 and x minus 4. And then I can factor 3x minus 5 no further, so I'm just bringing it down. And there is my fully factored answer. It doesn't say to solve it, so I'm not using the zero product rule or anything. I'm just factoring. All right, so here is our Pythagorean identity, right? So it's sine squared of theta plus cosine squared of theta equals 1. So because I'm seeing that written out perfectly, that means that this theta and this theta have to be the same values for this to be equal to 1. So that means A must be the same thing that is plugged in here. A is going to be equal to 34. All right, finding all of the solutions here. So if I'm going to graph this thing, or if I'm going to factor it, I'll start with that. I need to find two numbers that add to 8, multiply to 12. Excuse me, add to negative 8, and multiply to a positive 12. So negative 6 and negative 2 will do that. I don't know why I put a multiply there. They need to multiply to a positive 12. So those two add to negative 8, multiply to positive 12. So this factors will be x minus 6 and x minus 2, just like that. So if I'm going to put this on a number line, that means that I'm going to have a 0 at x equals 6 and a 0 at x equals 2. So 2 will come first, then a 6. They will both be open circles because this is just a less than, not a less than. So now I need to test a point in the middle to see which direction I'm shading. Usually when it's a less, I shade in the middle. So I'm just going to test a point here and see if it comes out false. A point between 2 and 6, I don't know, I'm going to say 3. I'm going to test the point 3. I guess that would be closer to 2 than 6. Whatever. So 3 squared minus 8 times 3 plus 12. So that would be 9 minus 24 plus 12 is less than 0. 9 minus 24 is negative 15 plus 12 is negative 3 is less than 0. This is true. So I am going to shade in the middle. So all of my solutions will be all of the values of x in between 2 and 6. Just like that. All right, inverse. So to find an inverse, I switch x and y. Now I'm going to do the circle of log to rewrite this. So it'll be 4 to the x power equals y. And there I have my inverse. Now it's asking for a solution set. So first off, I'm going to rewrite this kind of thoughtfully. I'm going to factor it. So this is going to be x plus 3, x minus 3. That's x squared minus 9 factored. Plus 1 over 1 equals 5 over x minus 3. So I need to give them a common denominator. So I'll start here. This is missing an x plus 3. So I'm going to give it an x plus 3. This is missing both an x plus 3 and an x minus 3. And then I can ignore my denominators because they are the same on both sides of the equation. So I'm going to get 30 plus x plus 3 times x minus 3 equals 5 I'll go ahead and distribute it. X plus 15. When I FOIL this, I'm going to get 3 plus, when I FOIL this out, I get x squared minus 9 equals 5x plus 15. Because it's a quadratic, I want to combine my like terms and get everything on one side. So when I combine like terms, I have this, oh, this is a 30, not a 3. So I have this 30 and this negative 9, so that gives me x squared plus 21 equals 5x minus or plus 15. I'll subtract both 5x and 15 from both sides. So when I subtract and bring everything down, I'm going to have x squared minus 5x plus 6 equals 0. If you notice the video just skipped, it's because I made a mistake and then I just caught myself when I went and checked my work. So I now have to find two numbers that add to negative 5 and multiply to 6. So add to negative 5, multiply to 6. So that looks like it's going to be two negative numbers. So negative 2 and negative 3 will fit that. So x minus 2 and x minus 3 are now my factors, set equal to 0, which means my solutions are going to be x equals 2 and x equals 3. Uh-oh, I just noticed that 3 is going to be a problem, because if I have a 3 in the denominator of my original equation, I'm going to have 3 minus 3, which gives me a 0, which means this is an extraneous solution and 2 is my only real answer. I went ahead and I graphed it earlier, so I put the first thing in my y1, I put the second half of the equation in my y2, and then I checked my table just to make sure. And sure enough, when x is 2, the two y's are the same, so I have a solution. And sure enough, when it's 3, I've got errors, so that is my extraneous. Next up, it is saying state the quotient and remainder when this division happens. So I'm going to do it. Alright, so let's see. I need to first figure out how many times x goes into 4x squared. So it goes in 4x times. X times 4x gives me 4x squared. Negative 3 times 4x gives me negative 12x. Now I subtract. Those cancel out, and 8 minus negative 12 is like 8 plus positive 12, which is 20x. Bring down the negative 29. Then x goes into 20x 20 times. Then I distribute. X times 20 is 20x. 20 times negative 3 is negative 60. 20. Now I'm subtracting. 20 minus 20, those cancel. Negative 29 minus negative 60 is like negative 29 plus positive 60, so that would be 31. So that means that my remainder is going to be 31 over x minus 3. Now I'm going to check that using remainder theorem. So remainder theorem states that if I take g of 3, excuse me, not g of 3, if I take f of 3, I should get my remainder. I'm just taking the thing I'm dividing by, I'm taking a positive 3. It's basically like that's what would make this 0, this g of x, and I'm going to plug it into f of x. So I'm going to be doing 4 times 3 squared plus 8 times 3 minus 29. And I'll use my calculator for that just to make my life easier. So 4 times 3 squared plus 8 times 3 minus 29 gives me 31. And hey, yay, that works. My remainder checks out. So here I've got the quotient and the remainder. Alright, domain and range. So domain is from my smallest x value to my largest. So here's definitely my largest x. My x max equals 9. It looks like my x min is actually right here. So that would be 4.25. I think it doesn't go all the way to 4. So my domain is going to include both of these points, 4.25 all the way to 9. The range is going to start here at the bottom, which is 0. and it's going to go up here to the top, which is 6. And both of those points are included as well, I believe, right? There's no open circle there or anything. Yep, we're in good shape. We've got the domain and the range. All right, it's asking me to find f of g of 3, so I have to do g of 3 first. So g of x equals x to the third power. So 3 to the third power is 27. 3 times 3 times 3. So then I need to do f of 27, which is going to be 27 minus 3, which will equal 24. And finally, I'm simplifying the following. So I need to take the cube root of all of these things. So I'm doing the cube root of 24 times the cube root of x to the 8th times the cube root of y to the 9th times the cube root of z to the 4th. So I'm looking for groups of 3 everything. So I'm going to go ahead and factor this. So 24 breaks down into, let's see, why am I doing it like that? I'm going to do a factor tree. 12 times 2, which breaks down into 6 times 2, which breaks down into 3 times 2. So I see I have a group of 3 2's that I can pull out, and I'm going to have a 3 trapped inside. So this is going to be rewritten as a 2 on the outside, a 3 on the inside. This one here, I'm looking for groups of 3. So basically, I'll just write it out. I have 8 x's. Looking for groups of 3, so I have one group of 3, 2 groups of 3, so that means I'm going to have an x squared on the outside, I've got my root, and I've got x squared on the inside. 2 groups of 3 came out, 2 x's are still trapped in. Here, I'm going to be able to pull out all of my 9's, right, because I've got, or all of my y's. I've got 9 y's, which is 1, 2, 3, 4 groups of y, so I'm going to have y to the 4th on the outside. Nothing left inside the radical. And in terms of my z's, I have 4 of them. I'm looking for groups of 3, which means that I can pull out a single z, and I'm going to have a single z trapped inside. So when I rewrite this whole thing, there's a 2 on the outside, there's an x squared, there's a y to the 4th, and there is a z. On the inside, there is going to be a 3, an x squared, and a z. And that looks like my final answer, and that is my answer key. So I hope it went really well for you guys. We're at the end of the test. Take care.